Welcome to Miss Math Presents Geometry SOL Prep G14 Similar Solids. First of all, we're going to start talking about our ratios of similar solids. If we have our length ratio, we would express that as x to y. For area, we square those numbers, so it becomes x squared to y squared. And volume, we cube it, x cubed to y cubed. If you think about the units you use for length, if you're measuring a room, you might use the length in feet. The area of the carpet would be in square feet. And then if you were using the volume of the room, that would be in feet cubed. So that can help you remember to square and cube the area and volume. Let's look at an example. If we have a length ratio of 3 to 5, for our area ratio, we square those numbers, so it becomes 9 to 25. Then cube it, 27 to 125. If we want to take area to length, then what we need to do is undo that square. And to undo a square, we do square root. And on your calculator, that's second x squared. To take volume to length, we need to undo the cube. To undo the cube, we do cube root, which on your calculator is Math 4. Now, another thing to note, if you see the word scale factor, that's just another term for your length ratio. So let's take a look too at changing dimensions. We're going to look at this with some examples. Whatever we do to one side of the equation has to be done to the other side. So we're going to do some changes to a cylinder's dimensions. Now, the same strategy works with any formula. Right now, we're just going to look at cylinder volume, but you can do this with any formula. So we're going to look at 3 different examples. We're going to look at when we change the radius, we're going to look at when we change the height, and then when we change the height and the radius, and see what each of these situations do. When we triple the radius only, we add or multiply a 3 with r. Now, r is squared, which means 3 has to be squared. And if we put a 3 squared on the right side of the equation, we have to put 3 squared on the left side. So the volume changes by 3 squared, or 9 times the volume. If we double our height, so we're going to multiply by 2, so our height changes by 2. Our height is not squared. So it is not squared on the other side either. So we have a 2 on both sides, so our volume changes by 2 times. If we triple our height and our radius is changing by 3, and the radius is squared, so that has to be 3 squared. Our height changes by 3, and that's not squared. So we have to have our 3 squared and our 3 on the other side of the equation. So when we multiply these out, our volume changes by 3 squared times 3, or 27 times the volume. Regardless of which formula you're working with, make sure that you make the changes to both sides of the equation, and you're good to go. Right. Finally, we need to look at finding the area or volume of a similar solid. You see here, we have the height of both cylinders. We have the volume of one cylinder, but not for the other. So we need to find the volume of the larger cylinder. The way we do this is first we want to get our length, area, and volume ratios. To get our length ratio, you notice we have our height of 6 to 10. Now, that's not simplified. Both of those are even numbers. So I'm going to put that as a fraction in my calculator and simplify that. 6 over 10 simplifies to 3/5. So our length ratio is 3 to 5. For area, I'm going to square those. 3 squared to 5 squared, so that's 9 to 25. And then for volume, I cube the original ratio. 3 cubed to 5 cubed, so it's 27 to 125. Now, I'm looking at volume, so the ratio I'm going to use here is the volume ratio. Now, let's set up our equation for finding out our volume here. So, I need to figure out which way to write my ratio. Do I write it as 27 over 125 or 125 over 27? The trick here is we pick which one we need, and that goes on the top. If we need the smallest goes on top. Here we need the largest, so the larger number is going to go on the top. So I'm going to use 125 over 27. So I'm going to take my ratio with my biggest number on top, since I need the biggest volume, and I'm going to multiply that by the volume of the other solid. So my ratio, 125 over 27, times my other volume, 75.4 inches cubed, and that gets me my answer. So my volume of my larger cylinder is 349.1 inches cubed. Thank you for joining me for Ms. Math Presents G14 Similar Solids, and I will see you next time.